All right, hello guys. Today we're back with another video that will be on exceptions. We can find exceptions on the left side, basics, concepts, control flow, exceptions. And we will read this document and add some code from my side to better understand it. If you are new, that's what we are doing in my Kotlin lessons. We have a bunch of lessons, starting from understanding Kotlin syntax, idioms, coding conventions, numerical types like integers, shorts, and so on. Then we have unsigned, booleans, characters, string types. Then we have also array types lesson. Then we have type checks and casts, and then conditions and loops. And in this slide, you will have a recap of all the things that we have studied together. Actually, it's not still updated. I'm very sorry. I will try to update it as soon as I can. And here, if you want, you can also see the code that we are writing throughout these lessons. So, of course, if you enjoy this type of content, please subscribe to the channel and also activate the notification bell so that you can join us when we're live streaming again. So let's start with the exceptions. Exceptions help your code run more predictably, even when runtime errors occur that could disrupt the program execution. So Kotlin treats all exceptions as unchecked by default. What it means, unchecked expressions simplify the exception handling process. You can catch the exceptions, but you don't need to explicitly handle or declare them. So you're not forced basically to do the checking on these exceptions. The exception may be there because you really want your code to crash, and we'll see some examples. I think we have already seen one with the to do like function in Kotlin that basically throws an exception. You can learn more, about how Kotlin handles exceptions when interacting with other programming languages like Java, Swift, and Objective-C. Let's see this part. Yeah, we will read this at the end of this of this topic, so we don't go on with that. Working with exceptions consists of two primary actions, as we said, throwing exceptions, so to indicate when a problem occurs, and the other action that you have is to catch the exception, which is when you want to handle an unexpected exception manually by resolving the issue or notifying the developer or the app user that something has gone wrong. Exceptions are represented by subclasses of the exception class. And this class is a subclass of throwable class. For more information about the hierarchy, see the exception hierarchy. Let's see, yeah, it's over here. Anyway, as we see, it's just a superclass or interface. We will check this later. And yeah, for example, you can have either a throwable error or throwable exception. And if you want something more specific, it would be like runtime exception or IO exception. And this is it will inherit from the exception class. So let's get back here. This is just a brief introduction, then we'll see it again. Since the exception is an open class, yes, as we can see here, we can confirm that it's an open class. You can create custom exceptions to suit your application specific need. So an open class, as we said in other videos, is basically a class from which we can perform inheritance, and by default, as we see here, classes are final, so they can't be inherited from. And to make them inheritable, which I was just confused because I couldn't read this properly, but yeah, to make it inheritable, you can mark that down with the open modifier, open keyword, and this way you can inherit from this class. So for example, you could create a runtime exception or your custom exception for this reason. Okay, so you can manually throw exceptions with the throw keyword. Throwing an exception indicates that an unexpected runtime error has occurred in the code. Exceptions are objects, and throwing one creates an instance of an exception class. So throwing an exception means actually creating an instance of that class. So that's what the throw keyword will be doing. To better understand the source of the problem, we can include additional information, such as a custom message and the original cause. For example, we can pass, as we see here, the message original cause illegal state inside the illegal state exception, and this way we can differ between two causes of the exception. For example, as you see here, if user input is less than 0, so if it's negative, we can say that it is negative. And so let's do this. We can start with our ninth lesson in the code, and we can create a function play with exceptions. I have done this inside a control flow just to have more clarity inside our code. And here we will do two basic things, like you remember that we learned about the when expression last time. So what we might say is, let's say that we have a value of 10, an integer of 10, and then we can say when a is in range from 1 to 10, then print instead of printing, we can do throw, and then we can say illegal argument exception. The number you entered is in range from 1 to 10. And what else we can do? We can say if a is okay, we cannot do it like this, but yeah, we can do if not in range from 1 to 10. I think I have to negate here. Let me check why. Expecting. Nope. When branch is never reachable. Oh, yeah, because expecting an element. We have done this before, so if nothing, yeah, it's like this. Okay, maybe it's not reachable because we're throwing the exception. Let's it's just a warning by the compiler, by the ID, sorry. So anyway, let's try it with the value of 12. We should, the number you entered is not in range. So let's run again. Let's see what we have here. Expecting an expression is or in condition. I missed the minor here, I think. Nothing was like this. Let's try and run it again. What is going on? Is it throwing the exception because I don't see it? So unresolved identifier, not, nothing was possible. Nothing. I want to try and rewrite it just in case I did something wrong. Let's try and run it again. Expecting an expression is condition or in condition. Maybe it expects also the else. I'm not sure. Nope. Expecting. Oh, don't need that. Let's try like this. It's better. Let me check. Let me copy this. I'm doing something wrong with the syntax, I think. Because sometimes when the IDE tries to help you, it actually doesn't. I couldn't see that I was adding the minor, and so when you need a range, you have to just put the number, then the two dots, and then the other number. And I was doing this wrong. I'm sorry. I made you lose time. But when we have done this now, so it will throw the exception and it will say that the number is not in range. If we change the number to something that is in range, we will get the exception saying that the number is in range from 1 to 10. But of course, that wouldn't be very useful. So here we can say now the code runs smoothly. So basically, if it's not in range 1 to 10, then we throw the exception. Otherwise, we don't, because that would be something you would do in your code, basically. If you think that number is not inside the range you want, then you can throw the exception and you can catch it later as well. So What else we can see is that throw exceptions in precondition functions. Kotlin offers additional ways to actually throw exceptions using precondition values. That include require, check, or error. So this require will check the user input validity. So basically, what are these? These are functions that you can use to assert the input result that you are placing against a certain exception that will be thrown if the condition that you place inside the require is not met. And then we will have check that checks the object or variable state validity. And then you have error that indicates an illegal state or condition. So these functions are suitable for situations when program flow cannot continue if specific conditions are met. This streamlines your code and makes handling these checks efficient. So let's type this and let's go on with the require. So use the require function to validate input arguments which are when they are crucial for the function's operation. And the function cannot proceed if these arguments are invalid. So if the condition in require is not met, it throws an illegal argument, right? Let me think of an example we can do. What can it be? Let me check what we had here. So we can do something on traffic light. It's from a previous example, but we can reuse it. So what a traffic light is that it's an enumeration class that contains the colors of the traffic light, and it also contains a variable which is called stop, and this variable is either true or false depending on the traffic light color. So let's get back here. What we might do is we might say require that when we have a particular traffic light color like red, yellow, or unknown, and then and no broken, no connection, that the stop value is true, and when we have green, we don't want that to happen. We want stop to be false. And if these conditions are met, then we throw an exception. So basically, we can create our traffic light indicator, and we can say traffic light. We can pick a color like red, and we can have traffic light indicator inside here, and then we can import the remaining branches or the else. And I want to say when the traffic light is green, then we want to assert, so we want to require. Yeah, here it's for input state validity. So that would be something like, let's change this to let me think of a interesting example. Like we could create a car, because it's better it's that you can understand it better, I think. So we can do a data class called car, and we can say Paul, the car is moving. False. False. Maybe, yeah, we can place it inside the data class. Okay, we have to add boolean. So this will say that the car is moving or not moving, and then we can create a car object. Okay, and create a car object, and we can say it's moving, true or false. Then based on the light indicator that we have here, we can assert that the position of the car is like moving or not moving matches the green light the traffic indicator that we set. So basically what we can do is if traffic indicator is green, we have to assert, so we have to require that the input validity of car, so car moving, is true. Okay, and when we have like car in condition of red, yellow, unknown, broken, or no connection, we want to have false. And if these two conditions don't apply, then we will get the driver. The driver might get fine, right? So in this case, the driver would not get a fine, but he must move, right? Let's see what we're getting. Runs, okay. Yeah, we get the exception. The driver might get a fine. Let me check why. So car is moving. Yeah, so this is because the car is moving and the traffic light is red. So this means that the driver might get a fine. And if, however, we place green, the driver will not get a fine, but he must move. So since this expression like require car moving is true, then the driver is not going to get a fine, and this expression will be true because basically the require will throw an illegal argument exception with the message that we passed only if the condition is not met. Right? So I can add it here just for clarity. Car is moving, and then here we have car moving, and then traffic light is traffic light indicator. So actually this require is for checking input validity, so like something that the user has entered, And in this case, we could say that user input is the variable moving inside the car, even though it's not a user which is in, making an input on this number, but we are doing it. And the check condition, on the other hand, will check the object or state variable state validity. So what we could do, let me think. Yeah, we could. Yeah, it would be the same to use require check in this case, because we are checking against an object or state validity. So like moving is our state or is our input. It depends on how you think of it. So you could interchange this. Actually, here you could put check, and here you could put check as well, and the result would be the same. But yeah, just remember that you have to use require when the user is setting this moving state, and you have to use check when this state is part of an object or a state. So yeah, for example, I would say that if there was a function here like on start car that was setting the variable like this on stop car, this moving would be a state of uh, your data class. And let's have at least one primary constructor parameter. Okay. Like Windows. Like which car does not have Windows? I don't think there is one. So if we go back here and we say car dot start car, then this for sure this is this moving parameter is a state, because you cannot change it with user input. You can change it only with a function. So I would say this in this case now it is a state, and we have to use the check function instead of the required function as we were doing before. Okay. Next, we can have the error, which indicates an illegal state or condition. These functions are suitable for situations when the program flow cannot continue if specific conditions are met. This streamlines your code and makes handling these checks efficient. Okay, yeah. All right, I read something that we already read. Sorry, guys. It's not that late, but my brain is starting to sleep. Okay, so we have seen the require, we have seen the check, and now we will see the error. So the required function allows you to perform podcasting after a successful check. The variable is automatically casted to a non-nullable type. These functions are often used for nullability checks to ensure that the variable is not null before proceeding. That's very interesting, like what we might have is something like this. Let's go on with a new data class that is called vehicle, more in general. And yeah, we can say vehicle has windows, and then this data class car inherits from vehicle, and we can pass here has windows. Let's say why it's complaining, because it has to be an open class, and we have to add override modifier here. So yeah, and we also have to add open here. So now we have a car, which is a vehicle. And what I want to do to perform this like nullability check that they're doing here is I want to check if car is a vehicle before proceeding with everything else. So what we can do is require that car is a vehicle, right? Yeah, it would say this is always true, but I want to suppress this check and go on. So let's run this, and it will say it will not print anything because this require is working. And after this check, we know for sure that we can use our object car without the need to cast it, for example. Well, what we can do is say car is car. It will always be false. Yeah, so this is not a useful check. Let's keep on going. So we understood how this require with nullability check works. We have also seen how this type of check works. For example, he says check not null. Some state might be set beforehand, and then they check if the state is not empty. This is similar to what we were doing, and same as before, performs mark casting. Let's go on with the error. The error function is used to signal a legal state or a condition in the code that logically should not occur. It's suitable for scenarios when you want to throw an exception intentionally in your code, such as when the code encounters an unaccepted state. This function is particularly useful when expressions provide an unclear way to handle cases that shouldn't logically happen. In the following example, the error function is used to handle an undefined user role if the role is not one of the predefined role and illegal exception throws. So we can have, yeah, as you see here, a user and his role, which is admin or guest. And when you pass admin, then everything is going to be fine. When you pass editor, yeah, everything is going to be fine. And when you pass viewer, all will be good. But if you pass the guest, then you will get an error. So we can do something similar. I want to do a test on traffic lights and see if all the values inside traffic lights are true for all the enumerators except the green. So let's do it over here. Check that the enumerators are set properly. So test traffic light indicators. And we create a function and we say when we want to iterate over traffic lights entries for each of these, we want to if traffic light, if it stopped is true and it is traffic light green, then everything is good. Sorry, if it's false, else it stopped is true, then if then all is good, otherwise we throw an error. Else we throw an error, so illegal traffic light dot value. See what they're saying. Unreachable code and it equals to traffic light green still unreachable. Yeah. If it's stopped, it's not stop and then it's green. If it's stopped and through, why is this? Maybe it would be more suitable to have something like we check the condition beforehand. So if it stops is false and it is something different from green, and we throw the error. Else we don't need this. Why is it still complaining unreachable code? It stopped. And it is not green. I don't understand. I think the compiler is making some jokes. I mean the idea, of course. All is good with traffic light entries. Let's run this and see if all is good. Yeah. Okay. Yeah. I'll print it only once, of course. And if we say this value unknown is false, then we should get the error. Yep. So this allows us to ensure that to test that all our traffic light indicators are properly set, because we only want stop to be true when the green is not green. Okay. When the sorry when the traffic lighting indicator is not green. So this check now runs properly. Let's go on with handle exceptions using try-catch blocks. When an exception is thrown, it interrupts the normal execution of the program. You can handle the exception gracefully with the try-catch keywords to keep your program stable. The try block contains the code that might throw an exception, while the catch block catches and handles the exceptions if it occurs. The exception is caught by the first catch block that matches if the specifier superclass or a superclass of the exception. Here's how you can use the try catch keywords together. So you can also, as you see here, specify the super type of the exception. So let's say that we have an exception here because the driver gets a fine, might get a fine because he is moving with a traffic light that is not green. So let's put ourselves in this condition. We have start car, so we're moving, but traffic light is not green, it is red. So we're going to throw an exception here. Let's run this. The driver might get a fine, so we are inside this condition. And we want our program to continue running. So in order to do so, we must catch the exception. So we have to do the try catch expression. And then we can catch with a generic expression, then we will change it. And then we want to put our when inside the try. And now we can catch the exception. Which exception is it throwing? We can check here. It's throwing illegal state exception. So when we print out here, we will see that the code is throwing illegal state exception E. Let's run this. And yeah, we can see that code is throwing illegal state exception, and it also prints out the message that we have set. But now the thing is that build runs successfully. So it does not stop the program, and this is very, very useful when, of course, you need the user to use your code, to use your app or your program. And if you don't catch exceptions, then your user will be the app of your user will be killed. So this is very important that you understand when the code is throwing exceptions and why. And you can have tools that enable you to understand why the code is throwing these exceptions, but we will see this in a later episode when we will have lots of viewers and so on, because I think I hope that you will stay with us until then. Okay. So it's a common approach to use a try-catch as an expression, so it can return a value from either the try block or the catch block. Okay, I also do this sometimes. For example, in this case, what they're doing is they're saying, okay, if the count function runs smoothly, then we assign the num a certain value. Otherwise, we assign a -1. And we can do this with another another type of value that we assign to this expression, and we can say takes takes fine, and we say if we are inside this function, so we have an illegal state exception, then the takes fine will be true, otherwise it will be false. And as you can see now, it is saying that this is a Boolean value, because in either cases we are assigning a true or a false value. And when, as we said, we have an illegal state, the 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 driver will get a fine. We can improve this by saying, yeah, I think it's better to keep this example like this. So I like it. Takes a fine, nope. Takes a fine, yes, when there is an illegal state. Although the user might enter an illegal state also here if the car is not moving and they have a green, but whatever, drivers must move. You can use multiple catch handlers for the same try block. You can add as many catch blocks as needed to handle different exceptions distinctively. When you have multiple catch blocks, it's important to order them from the most specific to the least specific exception, following a top-bottom order in your code. And we can see this very, very soon. For example, let's say, yeah, as you see here, illegal state exception is a child of runtime exception, which is a child of exception. So if we do catch illegal state, it's okay. And well, here we can do catch runtime. And this can also be, let's do true. And then we can have exception, right? So at this point, the code is not throwing, if it's not throwing an illegal exception, but a custom exception, then we will enter runtime exception or exception statement. We can say it here. Let's do something very, very quickly, like custom check function. Okay, and we will replace it back. Our custom check function will check the expression. Wait, why is it passing? Yeah, okay, I get it. So if B throw runtime exception, not B, and but before this, we have the function here. So let's copy what they're doing inside check. So instead of for this experimental value and lazy message. And then here we have value and lazy message. All right. So instead of having an illegal state exception, we can have an exception, a normal exception at runtime. And this time the code will enter the second block, not the first one, because it is not matching the first catch. It is matching the second catch. All right. Next, what do we have here? The finally block. The finally block contains code that always executes regardless of whether the try block completes successfully or throws an exception. With the finally block, you can clean up code after the execution of try and catch blocks. This is especially important if you're working with resources like files or network connections, and finally guarantee that they're properly closed or released. Okay, so what we could do in our case is that when all the code runs, after a certain time, like 2 seconds, we want our card to stop. So we can say finally, and then we can delay with 2 seconds. Basically, the delay is 2 seconds delay. Okay, so that's not possible to inherit it. Copy. Probably it's from, yeah, it's from another library. So I'm sorry, we cannot use it. But imagine that we had a delay then. Imagine we have a 2 seconds delay, and then we want to stop the card. Then you have 2 seconds delay, and then we stop the car with car dot stop car, and this will happen all the time because it doesn't matter if we are inside a catch or not. We will this code will run. So if we go back to green, everything runs smoothly. We don't have the exception, but we still enter the finally condition. Let's keep on working. The return value of the try expression is determined by the last executed expression. We already read this. So in Kotlin, the idiomatic way to manage resources that implement the autocallable interface, such as file stream, file input, or file output stream, is to use the .use function. This function automatically closes the resources when the block of code completes, regardless of whether an exception is thrown, thereby eliminating the need for finally block. Consequently, it does not require a special syntax like Java. Try with resources for resource management. So this will ensure that the resources are closed when the block of code completes. So I suggest that you use this if you're working with files instead of making the try catch. So if your code requires resources cleanup without handling exceptions, you can try with the finally block without catch blocks. So resource.use, and then you can have finally resource close. As you can see, the final block guarantees that the resource is closed regardless of whether the exception executes. Okay. In Kotlin, you have the flexibility to not to use only a catch block, only a final block, or both, depending on your needs. But a try block must always be accompanied by at least one of them. So we cannot have a try without a catch. Otherwise, it will say, "Hey, you're mad." You see here that it's saying, "Hey, you need the catch or the finally." Create a custom exceptions. In Kotlin, you can define custom exceptions by creating classes that extend the built-in exception class. This allows you to create more specific error types tailored to your app needs. To create a custom defined class, you can extend exception. Of course, we haven't done that here. We have done a custom check, but let's remove this and go back to our standard check function. Okay. And we create our custom exception. So what we can do in our custom exception. Let me see where it's might be an idea to call this maybe here. So instead of error, which basically throws an illegal state exception, we might have our own exception that says class legal traffic height indicator and we can say the traffic light, oops, sorry, to say an exception, traffic light indicator is legally set. And so instead of throwing this, we can say illegal traffic light indicator does not have a companion object, and that must be initialized here, and we initialize it. Or we might have an object as well, and that should work properly as well. All right. But yeah, I think it's better if we do it with a class. Exceptions in Kotlin are stateful objects carrying information specific to the context of their creation, referred to as stack trace. Avoid creating exceptions using object declarations. Okay, so it's saying that we should not use the object that I was trying to do here before. Instead, create a new instance of the exception every time you need one. So yeah, if you create an object, this object will be an instance of the exception class. So it's not good practice to do that, because each time you throw the exception, you must create the instance of the exception when you are throwing it. So that's why it's not a good idea to have an object here. Okay. I hope that's more clear from the comment there. Custom exceptions can also be a subclass of any persistent exception subclass, like the arithmetic expression like yeah, the arithmetic exception. Yeah, my cough is starting to grow. Sorry. If you want to create subclasses of a custom exception, you must declare the parent class as open, of course, as we know this. Custom exceptions behave just like built-in exceptions. You can throw them using the throw keyword and handle them with try catch finally. Okay, we know this. In applications with diverse error scenarios, creating a hierarchy of exceptions can help making the code clearer and more specific. You can achieve this by using an abstract class or a sealed class or a sealed abstract class or sealed class as a base for common exception features and creating specific subclasses for detailed exception types. Additionally, custom exceptions with optional parameters offer flexibility, allowing initialization with varied messages, which enable more granularity error handling. So let's take a look at this example. Let's see how much we have here. Yeah, we still have some code to read. So we have a seal class, which is a count exception, and we have an exception here. And so the account exception is inheriting from exception. And we can have invalid account credential exception, which is an account exception with a specific message. And same goes from API the expired exception. And then we have the two results here. Okay, this is, I don't know why they're doing it like this, but basically the idea is that we might do something like seal class, and then we might have illegal traffic light exception, and we can have ES error, which is the error message with strings. Okay, and we can have inside this seal class. Yeah, it's not inside, but or maybe yes, inside it. We can have a class, which is our illegal traffic light indicator exception. Maybe let's do traffic light exception. And here we have traffic light indicator exception. Then, so the traffic light indicator is illegally set. What we might do is if it stopped, not. Yeah, then this is not. It's not a very good example. I think we need to create a new example from scratch for this. But basically the idea of this is that this is that you can make any class you want to inherit from your seal class, and you can have different classes, meaning different types of exceptions, like legal traffic light or yeah, we can say unknown indicator exception. The indicator is unknown, or like else if it equals unknown, indicator, sorry, it equals traffic light unknown, then throw traffic light exception unknown indicator, right? So if we enter this, then the traffic light indicator is unknown, and we will get the exception. Let me just try and run this. So as you see here, the indicator is unknown. And if we want to fix this, we can do filter on it not traffic light unknown, and this way it will run smoothly. Okay. In Kotlin, every expression has a type. The type of the expression throw illegal argument is nothing. Okay, that's interesting. A built-in type that is a supertype of all other types, also known as the button type. This means that nothing can be used as a return type or generic type where any other type is expected without causing type errors. Nothing is a special type used to represent functions or expressions that never complete successfully, either because they always throw an exception or enter an endless execution path like an infinite loop. You can use nothing to mark functions that are not yet implemented or designed to always throw an exception, clearly indicating your intentions to both the compiler and code readers. The compiler refers a nothing type in a function signature, it will warn you. Explicitly defining nothing as a return type can eliminate this warning. So the Kotlin code demonstrates the use of nothing type when the compiler marks the function code following the function call as unreachable. Creates an instance of a person with the name as null. Then person name else fail, and this throws illegal arguments because if is null, so name is required. And this function will never return successfully. It will always throw an exception because it's designed to fail. Let's do this with another test, like test current traffic light indicator, and then let's pass this, and then let's see when this, and then when we have, yeah, okay. So if traffic light indicator is null, well, basically, if traffic light indicator is unknown, then we throw the unknown indicator exception, as we were doing in this function, in this test function. And then what we might do is we can return nothing. So we can return nothing. Why is it complaining? Never reachable. Let's run this. A return expression is required. Okay. So yeah, as we can see here, I think this. That what it is saying is that this returns nothing. So let me try and say all is current indicator known. Then we say true. If nothing, so it's true. Unreachable code. What's the purpose of this nothing? This function will never run successfully, would always throw an exception. S is guaranteed to be initialized at this point. Okay, so yeah, the exception is still throwing. This nothing is just to say that it will throw. So if I remove it, yeah, as you can see here, it will not add the warning. That's the difference, probably. So if we add nothing, then we can see the warning. But well, we cannot have something. It always throws an exception. Yeah, because okay, this function always throws it. And our function is not always throwing an exception, but just on some cases. So the idea would be to place this outside of this function. So this should not, or this should not return nothing, but it should return two types, like nothing and null. I know this is stupid, but that's what could happen. So if it's current indicator unknown, so basically if we have is of type nothing, then okay, it's not of type nothing. If is null, then we can say print line indicator is not unknown. And here it says it's always true, but that's only because this is not unknown. It still says it's always true. So yeah, from these tests, what we can see is that this is not a proper way to create this function. We should have it like this. It should be a function that fails, fail with unknown indicator, and the check should be done priorly here, and the check should be here. So if traffic pipe indicator is unknown, then we fail with unknown indicator, and else we go on. So it's true, and yeah, that's pretty much it. So let's remove these and get back to green. Let's see now. We have Kotlin to do, which always uses nothing type, serves as a placeholder to highlight areas of the code that need further implementation. So we already saw this, that to do can be used to declare a function. So like car can have function which is clean itself, and this function can be a to do because it's not implemented yet. So this will throw an error and it will return the type nothing. So if I call this inside our code, like car dot in itself, when I run it, it will throw the exception again, and it will say an operation is not implemented, and it will say not implemented because that's what I've written inside here. So it's better to say clean is not implemented, so something more specific. Then we have exception classes. Let's explore some common exception types found in Kotlin, which are subclasses of runtime exception. One is arithmetic exception, and this operation occurs when arithmetic exception is not possible to perform. So let's play with this inside our code. In itself is going to be commented out. Then placed here at the end. Then let's do about example to divide it by 0. So this will throw an arithmetic exception, and we can catch it. Exception, the arithmetic. Oh God. Let's copy it. Fetch. Sorry guys. Still late. So we can catch it and the code will still run. If you don't use the exception, then you can use this underscore, so that code, you will see that if you don't want to print anything or so on, it might be useful. in case you want to print it, of course, you have to switch to something that is has a certain label like E, and this way it will be printed out. Index out of bounds. So if, for example, if you want to remove something from a list, then it will throw index out of bound. We can throw it in a new try catch. Alt L list of 3, and then we catch exception, index out of bounds, exception, and then we can print line E. And anyway, we have to do some operation like remove. Okay, this is not a mutable list, it has to be a mutable list. L remove at, otherwise we cannot access the remove at function. If it's not a mutable list, we will see it. And as you see here, it will say index out of bounds, index 3 is out of bounds for line 3. To avoid this exception, use a safer alternative, which is get or null. And this can help you get the third element or remove. Yeah, you can see I've removed first or null, but this is not the use case that we want. If you want a safe alternative, they are saying you can do dot get and then get index 3, or you can do get or null, get or else, whatever you want. And if you do get or else, yeah, get or null, then you can say if get or null is not null, then you can remove it, and this way this will not throw the exception. As you see here, successfully remove the element, because we are checking if the element exists in the list first. Hey boy, why are we not printing it? Yeah, it's not printing because it's outside the range. So no need, basically here, no need to handle exception. Third element does not exist. So that's why we're not entering this. If we add the fourth element, then we enter the first if, and we remove the element and we print out the list as well. All right, so we can do no such element exception. The exception is thrown when an element does not exist in a particular collection. It occurs when using methods that accept a specific element, such as first, last, or element at. And if you try to access the first element of an empty list, it will throw something out. So let's try this. Print on element of list, we stop and we say this will be some integers. I want to get the first element, A, it will say you cannot, and no such element exception, and we can print no element in list. So this is also useful, but also remember that you have a safer alternative, and to avoid the exceptions you can say print line. I can print it before this element of null list, a list of integers, and then first or null, and this way it will not throw the exception. Okay, it will throw the exception only because it's trying to access the first element here, and here this is not a safe call, so it will throw the exception. Same thing with numbers. You can have number format exception if you try to switch from a string to an integer. So we can say string line switching from int into string now from string int is not possible. So what we can have is count int, and this will throw an exception, a number format exception. Ooh, true, and number format exception, and then here we can say inline it's possible to change string to int, and then if we run it we will have impossible to change the string to int. Yeah, we can have also the version with switching from string to int safely is possible with this function, like you have here. Hello dot to int or null, and this way it will output null. And that's really good. So I always prefer the nullable version, but then you have to remember that you have to check that if this is null, of course, in your code. So what you can do is we can have n, which is this, and then you have n here, and you can then use n. If n is greater than 0, you can use whatever you want. Print line greater than 0, and of course you have to surround with the null check. So and not null, and n is greater than 0, and you always have to perform the nullability check if you do string to number conversions. You might also place a proper number here to actually check the work you're doing. Null pointer exception. This is thrown when an app attempts to use an object reference that has the null value. This is very, very important. Even though Kotlin's null safety features significantly reduce the risk of null pointer exception, they can still occur through the use of double dots. So let's say that we have hello again here, and that instead of performing this not null check, we say, okay, I will risk it. I know that this element n is not null because I know it. What happens if I run the code again? It will break because the exception will say, hey, you're pointing to an object which is actually a null. That's interesting. I was forcing basically the compiler to believe that this was not null, and now I I'm I'm having an issue. So the safer thing here would be to check that the n is not null. I mean, when should you use the double um, double exclamation mark? You should use them when you know that the object is surely not null. For example, what you could do is not null check first, and then inside the not null check you can do n greater than 0. But what might happen is that the ID is not marked enough to tell you, and you might place the double exclamation marks inside next to the n. Okay, that's my suggestion. Exception hierarchy. The root cause of the exception hierarchy is the throwable. As we said before, it has two direct subclasses. The error subclass represents serious fundamental problems that an application may not be able to recover from itself, like out-of-memory error or stack overflow error, that you generally would not attempt to handle. So these are the errors are something you generally do not attempt to handle. They are handled probably by the Java virtual machine. Okay, so you don't need to 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 check this type of errors. There is no documentation here, but I would guess that's why. The exception subclasses, on the other hand, are used for conditions that you might want to handle. Subtypes of the exception types, such as runtime exception and IO exception, deal with exceptional events in apps, like runtime could be something that is happening, like we saw some like no such element exception, and this is a part of runtime exception. So anything that might happen at runtime. And IO exception is something with input output, like it could be due to database linking or connection or network connection. Yeah. Runtime is usually caused by insufficient checks in the program code that can be prevented problematically, like what we have done here. So with the first of null, we are checking if the list is empty before, and we're returning null. If the list is empty, else we're returning the first element. This check is preventing the runtime exception, and it's very important that you try and use those checks anytime that you try to access an element like first of all, like the first element of the list. Kotlin helps prevent common runtime exceptions like runtime and null pointer, and provides compile time warning for potential runtime errors such as division by zero. The following picture demonstrates a hierarchy or subtypes descendants from runtime, like arithmetic expression, index out of bounds, string index out of bounds, and number format exception. The stack trace. What is a stack trace? It is a report generated by the runtime environment, which is used for debugging. It shows the sequence of function calls leading to a specific point in the program, especially when an error or exception occurred. So let's see an example where the stack trace is automatically printed because of an exception in a JVM. We already saw this. So the running this code in the JVM produces this type of output, which contains the stack trace. So exception in main thread, and it also prints out at which line, so line 3. For example, here we have the exception type, the thread, and the exception message. Each other line that starts with at after the exception description is the stack trace. So this is basically the stack trace. A single line is called a stack trace element or a stack frame. So this single line is a stack trace or stack frame. And as we said, it contains the file and line number at which the method is called. So let's try and throw the exception again without capturing it. Let's go clean itself. So here we have our stack trace. It is this one, and this is a stack element, and it is saying, okay, clean itself. You called clean itself, and this function has thrown an error at line 41. In fact, we are at line 41, and this function comes from the function play with exception, which is a line 271. So I can click on it. Yeah, it does say, okay, you are running at line 271 of play with exceptions. So yeah, of control flow file, sorry. And this function is play with exceptions because the function that is running clean itself is play with exceptions. And then it will say, okay, it's at main line 42, as we see here, line 42, and then at main app apk. So this shows that the exception occurs in the main function at the main kt5. So main function is the father of our play with exceptions. In fact, that's what you can see here. It's Kotlin. Okay, so last thing is this. I don't think we have time because it was already a bit long. Since Kotlin treats all exceptions as unchecked, it can lead to complications when such exceptions are called from other languages that distinguish between checked and unchecked exceptions. To address this disparity, use @throws annotation. This annotation alerts callers about possible exceptions. For more information, see calling from Java interoperability with Swift and Objective-C. So basically, if you are interoperating with other programming languages, you should add throw annotation. Throws annotation. That's what they are saying. Okay, so I think that for all it's all for today. I will update this with you. So leave commit again. Let me check if we disabled the clean cell. Nope. So we'll catch it. That's the last thing that we do today. Right, I don't remember what to do. Throws, not implemented. Error. Yeah, this part of errors. So this shouldn't be handled actually, but the best way would be to comment this. That's why, because we have an error in this case, so we should not call the function. It's not meant to be called. And this is the difference between error and exception. We handle exceptions inside the code, how we've done here, but when we have an error, since it's an error, we should not catch it, but comment it. Okay, and then let's 9 lesson exceptions, and then let's push it, and it's available for you guys. So thank you very much for watching, and hope you have a nice evening. Bye, you all.